Okay, the Rohde schwarz is back together again. I cleared the short on the switch. From my previous video, I went round the front panel and checked all the switch contacts and found that this switch here was actually reading almost short circuit, about a couple of ohms. And initially thought it was probably the buffer switch that was connecting the keyboard switch to the interface. I've replaced, I didn't mention my last video, but the chip I had cut out on the first video, I replaced with a new chip. Made no difference at all. So I started to think, well, if it's just the keyboard, it's going to be backstream, so it's definitely going to be sort of like the keyboard side, or or maybe one of those chips on board, those buffer chips or whatever they are. So it's back together again. I have had this working. I do actually know it works now, so I'm just going to give you a demonstration. Power it up. Comes up with the IEEE interface check, and as you can see on the scope, it's actually running a 1 Hertz sine wave at the moment, and it's all working absolutely fine. Just a quick run through it all. It's pretty straightforward actually. You select continuous for continuous frequency, then you enter your frequency here by selecting where are we? Okay, frequency is lit up, so we say 1 kilohertz, and then enter. No, we don't. We go frequency 1 kilohertz. Okay, that's 1.1 kilohertz I pressed by mistake, but even so, you'll see on the scope here we've got a nice clean sine wave running. It's working nicely. It's all pretty self-explanatory. There was one thing that really did confuse me on this when I actually first got it going. When I had the meter set, I don't know if you can see there, it's difficult to see, but it says 1.99 volts EMF, which is basically equating to RMS. Now, when I had it set to the previous meter range, it read half of that, so when it showed 1 volt output, it was actually producing 2 volts RMS. And I've spoken to an engineer friend of mine, and he sort of couldn't really work out. And the only thing we could come to the assumption was that the 1 volt RMS is 1 volt from ground level to the top of the waveform, and not a peak-to-peak measurement. So it's not even an RMS, it's like half the peak-to-peak wave voltage. Anyway, so I've set it to EMF to tie in with the RMS readings of all my other bits of instrumentation. There have been, someone did actually ask me a question, why couldn't I have used the Hewlett-Packard for an accurate frequency? Well, it is accurate. It won't drift. But the only thing is you can't set it to exactly say 1 kilohertz or 315 hertz, because the way it sweeps, it does it in steps, and it's not sort of smooth all the way through. So if I enter 1 kilohertz, the actual internal oscillator of this isn't super accurate, and it was never designed to be. It's in spec, but that's what it is. It's at 1 kilohertz, I think it's plus or minus 1%. So you're going to get a shift of sort of like, I don't know, a couple of 10 hertz or something like that. So it's not hugely out, but it's not an accurate frequency generator really. Whereas this machine is. So let's try and do a sweep. So we do frequency sweep, and I think we do we enter the level. Now how do we do that? There's the start stop button here. So start frequency of, let's go 1 kilohertz, and then we'll do a stop frequency of 10 kilohertz, and then if we do sweep, I think, no, oh, start. When it says start, is it sweeping? I can't tell if it's sweeping or not. If it is, it's very, very slowly. Doesn't look like it's sweeping at the moment. So I have to go, still getting my head around how this thing works. That's level sweep, frequency sweep. So that's manual sweep. Logged in. Don't know how you get it to start. Let's just check again. Start frequency, stop frequency. It says reset, sweep reset. So reset. And how do we get it to sweep? There's a bit of a learning curve. I've had this sweeping actually at one point, but I can't get it to sweep now. Oh, step. One step. Step time 10 milliseconds. Oh, I don't know. I'm going to have to read the manual. Oh, there we go. Sweeping. There you go. So that's 1 kilohertz to 10 kilohertz sweep. You can do it logarithmically or linearly. So either it sounds like a continuous tone sweep or a linear sweep, which would be the electrically correct sort of formula. So basically, like a logarithmic control on a volume pot. If you put a linear volume pot on a amplifier, you'll find that you'll get full volume more or less straight away because it's a linear scale. Whereas on logarithmic, like a dB range, you know, if you a 1 watt amplifier, a 2 watt amplifier won't sound twice as loud. It's all to do with the log scales, and linear scales a bit complicated, really. So that shows that's working okay. And then we've got different selections here for different outputs, for balanced outputs and things like that. We've got our storage memories here. This is the variable encoder that allows you to adjust the frequency manually. You can see like that. And then there's other special functions to get the thing to power up with the default program, and there's a pull-out card at the bottom here. So it's working really well. Good repair. I was a little bit concerned that I wasn't going to get this repaired, but it's working fine now. Thanks for watching. I'm going to finish off the Hacker RP30 now and do a scale alignment, so that'll be the next video. Thanks for watching.